Science is weird. It works incredibly well, but it offers no guarantees. We often talk about scientific facts as if they're unquestionably true, which is understandable. Modern life is built on these facts. Airplanes fly, antibiotics cure infections, and your phone can reach across continents to connect you to people you've never met. So clearly, something must be working. So what's the deal? What am I getting at? Well, I'm not trying to deny science. I just want to understand why it works and why we trust it. Now, what I'm about to say may come as a shock to you, but science does not deal with absolute truths at all. Science is a method more than a final say. It'll always be the best explanation we have so far, rather than the perfect answer. Scientific claims are provisional. They work for now until better evidence comes along. So hopefully we get less wrong each time. But different kinds of truths do exist. It just depends on the domain. Scientific truths are testable, revisable, but are always an experiment away from being overturned. Mathematical truths are true only within the axioms we choose. The truth changes when the rules change. And personal truths are real to you but unverifiable to anyone else. So these different kinds of truths coexist and shape both our subjective and objective sense of reality. Scientific knowledge grows through a cycle of observing, testing, reviewing, and repeating. What survives repeated attempts to disprove it becomes our most reliable model of the world, but never an undeniable certainty. Karl Popper, a philosopher, pushed this idea further with his theory of falsification. He argued that science shouldn't strive for proof, but should instead chase disproof. Science should try to prove itself wrong, and if a theory can't be falsified, it's not science. History gives us countless examples of this process in action. For centuries, the geocentric model of the universe was accepted as a fact. People believed Earth sat at the center of the universe, not because they were dumb, but because that was what their knowledge was pointing towards. Then, Galileo and his telescope revealed evidence that contradicted this view. When he looked through his telescope, it revealed Jupiter's moons and phases of Venus that supported a heliocentric model, where the sun is at the center, not Earth. This idea, condemned at first, challenged the geocentric ideal, but eventually the discovery was backed by more evidence that pointed towards his conclusion. Our understanding of the cosmos and subsequent reality shifted, and as our tools improved, from microscopes, telescopes, to particle accelerators, our understandings did as well. Even the most stark truths, like gravity, aren't absolutely guaranteed. It would be real shocking if gravity changed tomorrow, but not logically impossible. Unpredictability is always there, though it may not be as irrational as we initially think. The point isn't that we know everything, it's that science will change with the evidence, and that adaptability is the closest we can get to truth. To return to the claim that scientific facts cannot be entirely true, we can look to the relative nature of our world. Variables get in the way, conditions are always changing, and modern influences sway thoughts. Yet the core of science wishes to understand the natural world by constantly redefining the truths, without guarantee. That is the nature of science and why it works so well.